All right. So today we're going to focus on word problems. We did a little bit of word problems yesterday. The big idea here is that sometimes the triangle is not drawn for you. So you have to fill in or draw the triangle and then read the description in the problem and see where those pieces fit inside the triangle to make it look like a problem that you've seen before. And then you can find the missing side or missing angle, depending on whichever the problem is asking for you to find. Okay, so I think we started a little bit on page 10, the bottom of page 10, with the snowboard problem. So let's continue looking at word problems, but the idea is the same. You fill in as much as you can in a triangle, and you're just either finding the missing side or missing angle. So I'm hoping that we can get through a lot of these problems by halfway through class, and then I'll have a quiz review for you guys to work on. So quiz will be short. It'll be 1 page, 5 problems, and on the back is the morning review. So if you want to come in for the morning review, you're welcome to come in for that, or you can work on your own. I'll put the key on the website. I'll send out a reminder, and I'll tell you where the key is so you can check your answer. All right, so let's go to page 11. Okay, in this case, the diagram is drawn for us. A child holding on to the string of a kite gets tired and decides to put the string on the ground and secure it with a brick. The length of the string from the brick to the kite is 240 feet. If the angle formed by the string in the ground is 50.275 degrees, how high is the kite? Okay, so the figure's drawn for us, which is nice, but do we think we were able to draw this diagram without just based off the description? Okay, so we should be able to understand that all these problems are a triangle, right triangle, so we can just draw the triangle. Imagine the location of the brick, the location of the kite, the angle, the height, and then the length of the kite, okay, or length of the string. Okay, so pretty straightforward here. Part A, if the angle formed is 50.275 degrees, how high is the kite? So which variable in this case are we solving for? H. Okay, and would you use sine, cosine, or tangent to set up sine? Okay, try that. See if you can set that up.
Sine.
Okay.
Why would we use sine?
Okay, why would we use sine? So we always want to start off with our angle, right? So our angle is 3.275 degrees. We're solving for h because we know that's the height. We're going to ignore the d because too many variables is not going to be helpful. So we'll cover that up, and we're going to take advantage of the hypotenuse because hypotenuse is information that we do have. So that's why we want to involve information, a side that has a known value, and then we look for the unknown value. But yeah, we would not want to use tangent because if we use tangent, we have h over d, and that's too many variables, right? We want to strategically choose a trig function that will allow us to just have one variable to solve for. And then we can worry about d later. Cross multiply. Okay, any questions with A? Okay, part B, what is the horizontal distance between the kite and the brig? Okay, so now which variable are we solving for?
D.
D, okay. We could use cosine or tangent, but what's an easier option potentially? Pythagorean theorem, right? So if I have two known sides, solve for D easily. However, if you want to use cosine and do cosine of 50 equals D over 240, that'll work as well. So I worked out the problem using cosine, but I also used the Pythagorean theorem. Either way, we should get the same answer. Yeah.
Use the tangent.
Yes, you can use tangent as well. Good. Yeah, you can use tangent as well. Because you found that, the height from part A, tangent should also work. Yeah, that's fine. Right now, I don't really have a specific rule where, okay, we're all only rounding to first decimal, second decimal, third decimal place. But right now, things are fine, but on the quiz or test, I'll specify to the 10th, to the 100th, to the 1000th. So right now, I just did it to the 10th, but depends on the directions. So that's fine. You did 0.38, that's good too. Anybody still need to look at this problem? Are we all okay? All right, let's look at example 5. Okay, so submarine traveling at a depth of 250 feet dives at an angle 15 degrees with respect to a line parallel to the water surface. It travels horizontal distance 1,500 feet during the dive. What is the depth of the submarine after the dive? So this one's a little bit messier, but we're still dealing with a triangle here. So let's not worry about 250 feet yet. Okay, let's just focus on where this submersible is located and the triangle that it's involved here. So I'm just going to draw a little diagram here. And so here's my triangle. We have this line that is parallel to the surface of the water. It travels a horizontal distance of 1,500 feet during the dive. So we know that over the, even though it's going this way, it's telling us this word horizontal is giving us a clue that the 1,500 is going to be dealing with this that horizontal line. Okay. Angle of 15 degrees with respect to the parallel line. So we know it's 15 degrees. The submarine is actually going to be taking this route. And then wants to know what is the depth of this submersible after the dive. So we're going to find this depth. Okay, let's solve for x, and then let's worry about that 250 feet. Okay. So if I want to solve for x, which trig function? Yeah, go ahead. Try tangent.
How come we didn't use the 250 feet?
Not yet. So right now, let's just focus on where the submarine is and how far it's gonna drop, and then I'll bring in that 250 a little bit later. Okay, but right now, imagine the 250 is up, above that submarine, so we're just going to solve this problem first, solve for x first. All right, what do you guys get for x?
41.92.
Okay, 401. So we know that this submarine is gonna, from where it's at, it's gonna drop down 401 feet. But before it begins its descent, how far is it below the water? 50 feet. So now the question is, how far below sea level is this submarine, and what would you do?
600.
And how'd you get that? Add it, right? So we add the 250 because that's where the submarine is before it begins its descent. And then it's going to drop down another 400 feet. So to figure out how far it is in relation to the top of the water surface, we add those two together. Okay, any questions with that? All right, I want you guys to read number 6 and try your best to fit those numbers into a triangle. And we'll compare our setup, and that will kind of give you an idea as to, are you able to interpret in the correct way, or we need to continue working. So, look for context clues, right? let me read the problem and let's make sure that we're filling in the values in the correct spots. It says the steepest railway in the world is the Katoomba Scenic Railway in Australia. Passenger cars pulled up the mountain by twin steel cables. It travels along the track 1,020 feet to obtain a change in altitude of 647 feet. So steepest railway. So when I think of word steep, I know that it's slanted, right? So we know that this railway is moving up, right? So we know that the railway is kind of built along this hypotenuse of this triangle. So that's where the 1020 goes. Right. Kind of imagine that this railway is moving up the mountain, so it's going to have that. So that's why it's part of the hypotenuse. Whenever I see the word altitude, that indicates to me we're talking about the vertical heights. And it says find the angle of elevation. Angle of elevation is always the bottom corner angle. That's the hard part. The hard part is filling in those values into a triangle, because from here, now just solving for theta using trig. So what can we use? Sine, yep. Any questions with part A? But now part B, how far does the car travel from a horizontal perspective? So which part of the triangle can we now find? This
So the
part.
bottom part.
Yeah, the bottom part, right? So we'll call this X if you want. And how can I find that? The Van theorem, yep. Or you can use any trig function. I'm sorry, not any trig. You can use cosine, you can use tangents. But Pythagorean theorem, if we can, right, it's usually the easiest way to go.
Should I ask the thousands or something?
No. Right now I don't have a specific consistent rounding, so you can round to whichever right now. Just know that on the test for quiz, I will specify the direction. I'll say 10th or 100th, but right now I can just do 2 or 3 decimal places. Either's fine. All right, so there's one more type of problem that you haven't seen, and this is the most difficult type. The type where you got to deal with a triangle within the triangle. And the strategy there is we're going to draw the diagram, but we're going to separate the two triangles so we can just handle them one at a time. And then we can piece together what the problem is asking us to do. Okay, so BX is on page 12. And we're just going to do 43 and 45. Okay, so I think the ones above are more straightforward. So we're going to use all that space for 43 and 45. So page 12. So go ahead and put 43 above here, and we're just going to read the problem, and we're going to we'll use the top half of the space to do 43, and the bottom half to do 45. Now the diagram is drawn for us here, so that's nice. But let me read the problem first. Both Derek and Sam are 5 feet 10 inches tall. Derek looks at a 10-foot basketball goal with an angle of elevation of 29 degrees. Sam looks at the goal with an angle elevation of 43 degrees. If Sam is directly in front of Derek, how far apart are the boys standing? Okay. Okay. We don't have to worry about the fact that Derek and Sam are 5 feet 10 inches, and the goal is actually we do. Sorry. So I will just set that up in a second. But for now, look at how the triangle is drawn here. So we're going to copy that triangle over here. Now this triangle is kind of floating in the air, right? The triangle is not with the ground. It's going to be at the height of both Derek and Sam. So Derek is the one that's further away, so I'll put D here. And then S is Sam. I'll put S here. Now, the height of this triangle is going to be the difference between the goal and the height of the players. Okay. So we're going to do 10 minus and 5 feet 10 inches tall. So 10 inches, we know that 12 inches make up a foot. 10 inches out of 12 is 0.83. So basically, we can think of the height of the players as 5.83 feet. So basically, the height of this triangle here is going to be 10 minus 5.83, which is 4.167.
Wait, why do you subtract 10?
What do you subtract 10? Okay, so this is the height. The bottom of this triangle is the height of the players. Okay, so this is 5.83 feet. But then the goal is 10 feet. So then we just subtract the difference because this triangle is floating in the air. It's not being measured from the ground. It's measured from the heights of the players. So we do 10 minus 5.83, and that gives us 4.167. 5.83. Okay, so it tells us that both Derek and Sam are 5 feet 10 inches. So 5 feet, that's fine. 10 inches is a decimal, right? So 10 inches is 10 out of 12. So if I do 10 out of 12 in the calculator, it's 0.83. That's fine. So I'm adding that decimal value to their height. So 4.167. And let's fill in the angles here. 29, 43. Okay, are we okay so far? This is the initial setup here. Okay. Now, we want to figure out how far Derek and Sam are away from each other. But before we do that, let's pretend like we have two separate right triangles. Okay. So let's draw two diagrams here. One triangle is going to be involving Sam and for the 43 degrees. And then the other triangle is going to involve Derek without Sam's information. So I highlighted Derek the red and the green. So I'm going to separate them and just worry about them individually. So let's do Derek here. Derek is in red here. Sam is in green. I'm going to fill in both triangles. Okay, everybody see what I did here? I separated two problems, and I know that Derek and Sam, distance is going to be involving these distances. Okay, so I'm going to just focus my attention on trying to figure out how far each of them are from the goalpost, or from the basketball goal. So I'll call this X, and I'll call this Y. So we're gonna separate the problem. We're gonna ask figure out how far Derek is from the goal. We'll figure out how far Sam is from the goal, and then from there we can figure out how far they are from each other. Yes, question. Go ahead. So we're gonna solve these problems individually. What can I use to tackle this X value? Tangent. Okay, so let's set up using tangent. Divide both sides by tan 29 to get that X by itself. So now we know Derek is 7 feet away from the goal, or 7.5 feet away from the goal. All right, let's look at Sam. Same thing, right? We can solve for Y, figure out how far he is horizontally from the goalpost using tangent. Okay, we're expecting a smaller value, right? Because Sam is closer to the goal than Derek, so 4.469, that makes sense. So if Derek is 7.517 feet away from the post goal, and Sam is 4.469, then what can I do to figure out how far they are apart from each other? Subtract them, right? If I subtract this from this number, then I can figure out the remaining distance between Derek and Sam.
I kept different calculations. Like I got 4.17 for the side length of the whole triangle, and when I said the question wrong, I like rounded at the beginning.
Yeah, so to increase our accuracy, we want to hold on to our decimal value in the middle of the problem. We usually want to round a little bit later. Otherwise, the accuracy is going to be changed over the course. So yeah, I'm going to hold on to that decimal, make it a little more accurate so that my end answer is a little more accurate. But the important thing right now is the steps. If you can understand the steps, then I care more about that. Okay, do you guys get 3.048 feet? Yeah. So this is long. This is the most difficult type of problem, right? Where you have to figure out the fact that you got a triangle within a triangle, but you really don't want to try to do it all in one go. You want to try to separate them, individualize each piece, and then make those two results come together and figure out what you're looking for from that information. Okay, let's do another one with a similar setup where we see a triangle within a triangle, we separate them, we solve each missing side separately, and then we find a way to involve them in finding our answer. Yes.
Right, just put in the numbers from my calculator and do 3.049.
Yeah, same. Wait,
Oh.
never mind.
So you mean you're a little bit off?
Yeah, because I.
That's fine.
I'm in my calculator, so it's like.
That's fine, that's fine, yeah, so I'm more interested in your setup. If your decimal is slightly off because you're rounding it differently than me, that's not a big deal for me. I care more about your steps. Number 45, lighthouse. Okay, let's read this problem here. Two ships are spotted from the top of a 156-foot lighthouse. So I have a lighthouse here at the top of my triangle here. So this is 156 feet. The first ship is at 27-degree angle of depression, and the second ship is a 7-degree angle of depression. So we have one ship A that's a little bit closer, and we have a ship B that's a little further away. Now we talked about angle of depression, right? We're going to treat angle of depression the same way as what? Angle of elevation, okay? So we're not going to put the angles up here, okay? The angles up here is not going to be correct. Let's put the angles down here. So we know that for angle A, the associated angle is 27 degrees. So put the 27 down here. And the 7 degrees, right? The further out you look, the less you have to look down. So it's a smaller degree further away you are. Determine the distance between the two ships. Okay, so same idea here. We'll split up into two separate right triangles. One that just involves A, and then the second triangle, one that involves just B. And then we'll find their horizontal distances separately, and then we'll try to put those information together. So virtually the same steps as before. Okay. Find X, find Y, and then guess what we're going to do with them? Subtract them. Yeah, so try that. Same steps now as the previous problem. Go ahead. right, let's start the quiz review. We'll try to work through page 1. Tomorrow morning, I'll go over page 2, but I'm going to put both keys on the website. So if you want to work through it on your own, you're more than welcome to. But let's start off with worksheet 1. Any questions with this? Are we okay with this setup? Okay. All right, if secant of theta equals 3, find the 5 remaining trig ratios. So what's the ratio for secant? It's the reciprocal of what? Sine goes cosine, yeah. Sine goes to cosecant, cosine goes to secant. So we know it's hypotenuse over adjacent, yeah, because you know cosine is adjacent over hypotenuse, so secant is hypotenuse over adjacent. And if I want to force that 3 into a fraction, what would that be? 3 over 1. So we're going to draw a triangle with the hypotenuse being 3 and the adjacent being 1. Okay, Pythagorean theorem. Find that third missing side, and then we can fill in all the trig ratios for all the trig functions. So you can either say root 8 or 2 root 2. Okay, so sine of theta is opposite over hypotenuse. Or if you're using that root 8, you can say root 8 over 3. Tangent, opposite over adjacent. Cosecant is the reciprocal of sine, right? So hypotenuse over opposite. Now I want to rationalize the denominator here, so I need to multiply top and bottom by what? By root 2. Or I can say 3 over root 8. Cotangent. Cotangent is adjacent over opposites. Finally, cosine is adjacent over hypotenuse. Okay, number 2, solve the triangle. So that means we want to find all the missing pieces. Questions?
Yeah, how did you get 3 over 8?
That's if I left the opposite as root 8. There's 2 root 2 sitting as root 8.
Okay. Oh, gotcha.
So adjacent over hypotenuse. I'm sorry, adjacent over opposite. Okay, number 2. We're going to use trig to find the first missing information, and the rest we can use easier methods. So here, we can solve for angle A or angle B, it doesn't matter, but it looks like angle B is already indicated with theta. So it's going to target theta. So if I want to target angle B or theta first, which trig function would I use to set that up? Tangent. You can use B or theta, doesn't matter. Got to involve inverse if it's angle that we're looking for. So now it gets easy. If I know that angle B is 28.8 degrees, then how can I find angle A? Yeah, add them together. We know we got to add it to 180. Or you know that angle A and B must add it to be 90 because 90 plus 90 is 180, right? You know that there's already a 90 taken care of with angle C, so you know the other 2 angles must add up to be 90 because all the angles add up to be 180. So you can subtract from 180, but if I subtract from 90, it's a little less calculations here. Either way, you'll get the same answer. There's one last piece that we need. Yeah, hypotenuse, so Pythagorean theorem. Okay, bell's about to ring in a couple of minutes. Go up and grab your phone. I will post these solutions on the website. I'll send you guys a link. Make sure so that you know where to find it. Tomorrow morning, 7:30, I'll go over worksheet B, worksheet 2 on the back. But if you can do everything on your own at home and you check your answer, then there's no need to come in. I think it should be good. Okay, I'll also remind you to bring your calculator tomorrow. So please tomorrow, very similar to this, 5 problems.